Number 65, a deposit of $570 is made into an account which earns 4% interest compounded continuously. Determine how much money will be in the account after 15 years and determine how long it will take before the initial account value triples. All right, so this is compound interest, compounded continuously, and that's the formula that future amount is equal to the present amount or principal times e to the RT, where t is time in years, r is your rate as a decimal, p is your present amount or principal or amount deposited or borrowed, and a is your future amount. So it says a deposit of $570 is made, so that's P, into an account which earns 4% interest, so R is 0.04, compounded continuously. Determine how much money, so determine A, will be in the account after 15 years. So time is 15. So that's A equals P 570 e to the 0.04 times 15. So we can type that in here and calculate 570 e to the, so second ln, 0.04 times 15. And that comes to $1,038.61. Right, 1,038.61 rounded to the nearest penny. All right, then it also says determine how long it will take before the initial account value triples. So that's asking how long. So time, how long? Switched over to a pen. That's a mistake when you're doing mathematics. Ah, well, how long? So t equals what? For the amount to triple. So that's for the future amount to be 3 times the present amount. So you put in 3p for A, P is P, and E is E. The rate is 0.04, and the time is what we want to solve for. So first thing we do is divide both sides by P. Now I could have put in the 570 for P, but then this would be 3 times 570, and we'd be dividing both sides by 570, and so it would come out the same way. It turns out it doesn't even matter for this kind of situation what the initial amount is. To find out how long any amount takes to triple still reduces to this equation. And so then you take ln of both sides to undo the exponential. Ln of e to the 0.04t is just 0.04t. So that's equal to ln of 3, and then you can divide by 0.04 to get your time. So calculating that, ln of 3 divided by 4, divided by 0.04, excuse me, is 27.4653, let's just say 27 and a half years. All right. Number 66, solve the following system of equations using a matrix. All right, so here what we want to do is set up a matrix that has just the coefficients of the x, y, and z and the constants. So the first row is going to be 7, -6, +6, negative 31, just like this. And then the second row is going to be 8, 7, 5, negative 41. And the third row is negative 1, 5, 6, 25. All right, so here's where we get to go to the calculator, and I'm going to use this calculator because it's much nicer for matrices. When you go to matrix, which is second x to the negative 1 power, matrix is above the x to the negative 1 power, you first want to go over to edit, and you've got to tell it that it's a 3 by 4 if it's not already programmed that way. And you can see in this calculator it's really really nicely displayed. The other one wraps around and you have to really pay attention and then call it up later to make sure that you put in the right numbers. This one you can see it all at once, which is one of the things I like about this newer calculator. Also, the fact that this one can be charged is a bonus. Alright, so if you have this calculator, you can proofread it just right here. Negative 66, negative 31, just make sure that you type everything in correctly because that's very, very important. If you have the other calculator, well, either calculator, we need to quit out of there. So second mode to quit. With the other calculator, you need to go back in second matrix and hit enter, and enter again to pull the matrix up in order to proofread it so that you can see it all at once. So once you've confirmed that you typed it in correctly, go back to second matrix, and this time over to math, and down to RREF, which stands for reduced row echelon form. Right, so you want to skip by the REF, which is just row echelon form, to reduced row echelon form. And you pull that up and then go back to matrix one more time to pull up matrix A. Just hit enter and then enter to do it. And that puts that matrix in what's called reduced row echelon form. So let's write that matrix down. We've got 1, 0, 0, negative 7, and 0, 1, 0, 0, and 0, 0, 1, 3. All right, so this matrix, just like the initial one, corresponds to equations, where the first position is the coefficient of x, the second position is the coefficient of y, the third position is the coefficient of z, and the fourth position is the constant on the other side of the equation. So if you write those down, what you see is that 1x plus 0y plus 0z equals negative 7. So x is negative 7. And the second equation here is 0x plus 1y plus 0z equals 0. So in other words, y equals 0. And finally, the third equation is 0x plus 0y plus 1z equals 3. And so z equals 3. And there's your solution for x, y, and z, which we write as an ordered triple. Negative 7, 0, 3, which is a point in 3 space, where those 3 planes intersect. Number 67. Solve the following systems of equations. System. Oh, hang on, my cats are fighting. Let's go over here and break this up. What are you guys doing? Huh? What are you doing? Stop it. I think they're okay. They're just playing. Sorry about that. All right, number 67. We've got y equals x squared minus 6 and negative 2x plus y equals 9. And we need to find the pair of points, the pair of coordinates x, y, that make both those equations true. And there might be more than one of them. What you want to notice here is that this is a quadratic. So the graph of this is a parabola, whereas this is a linear equation. The graph of that is a line. So we're looking at where does this parabola and this line intersect. So algebraically to find it, what you want to do is substitute x squared minus 6 in for y in the other equation. So you get negative 2x plus x squared minus 6 equals 9. And then you can set it equal to 0 and solve for x. So x squared minus 2x, you got a minus 6 here. You need to subtract that 9 from both sides. So you get a minus 15 equals 0. And factor x and x, two numbers that multiply to give you a negative 15 and add to give you a negative 2 would be negative 5 and positive 3. So x is 5 or x is negative 3. So then you need to take each of those values of x and go back and see what's y. So we can go back up here to where we have an equation solved for y and see what happens if you plug each one in. So if x is 5, y would be 5 squared minus 6. 25 minus 6 is 19. So that gives us the pair 5, 19. X is 5, y is 19. And similarly, if x is negative 3, plug in negative 3. And you get 9 minus 6, which is positive 3. So negative 3, positive 3 is the other solution. Let's look at this graphically. You can solve these graphically. If you look at this first equation solved for y, and then the second equation solved for y would be y equals 2x plus 9. So we can graph these. Of course, this is just your parabola shifted down 6 units. This is your line with y-intercept 9 and slope 2. All right, so let's go to y equals. Clear out what's in there. And y1 is going to be x squared minus 6. And y2 is going to be, cats are at it again, 2x plus 9. And let's go with a standard window, zoom 6. There's the parabola. There's the line. All right, so we actually can only see one of the intersection points right there. It looks like the point negative 3, 3. Yep. And in fact, you can have your calculator find it if you go second calc, intersect, number 5. And when it says first curve, hit enter. When it says second curve, hit enter. And when it says guess, just move your cursor close to the point that you want it to find. Negative 3, 3, sure enough. Now the other one, it's a good thing we did the algebra because that one's off the window. It's got a y-coordinate of 19. So to see that one, we'd need to change our window to go up to at least 19. So let's change that to 20. And then when we graph that, we should see, sure enough, there's another intersection point, and we can find that by going second calc intersect and telling it, yes, that's the first curve, and yes, that's the second curve, and now we want you to find this one over here. 519, sure enough. So that confirms those solutions.